Why's Earth spinning faster? Shortest day ever explained. Our planet is spinning faster than ever, and scientists are scratching their heads trying to figure out why. Imagine a day that's just a tiny fraction shorter than usual. So short, in fact, it could become one of the shortest days in recorded history. But here's where it gets controversial. While Earth's rotation has been slowing down for millions of years, it's suddenly speeding up, and no one can fully explain it. This Tuesday, August 5th, is expected to be one of those days, with the planet completing its rotation between 1.25 and 1.51 milliseconds faster than normal. Sounds insignificant, right? After all, a millisecond is just 0.001 seconds, barely enough to notice. Yet this tiny shift has scientists buzzing. According to predictions by the International Earth Rotation and Reference System Service and the U.S. Naval Observatory, this will be the third time this summer that Earth's rotation has sped up, following similar events on July 10th and July 22nd. If the initial prediction of 1.51 milliseconds holds true, August 5th could rank as the third shortest day ever recorded, trailing only June 30, 2022, 1.59 milliseconds faster, and July 5th, 2024, 1.66 milliseconds faster. But even if the updated prediction of 1.25 milliseconds is accurate, it's still a remarkable event. And this is the part most people miss. These speed-ups aren't just random blips. They're part of a larger trend that's challenging our understanding of Earth's behavior. So, what's causing this sudden acceleration? The leading theory points to the moon's position relative to Earth. When the moon is farther north or south of the equator, its gravitational pull can influence Earth's spin. On August 5th, the moon will be significantly south of the equator, likely contributing to the faster rotation. But here's the kicker. While the moon's orbit explains some of these speed-ups, it doesn't fully account for the recent trend. Scientists are now exploring other possibilities, including a bold hypothesis that Earth's core may have started slowing down around 2010, paradoxically causing the planet's surface to spin faster. However, this idea remains unconfirmed, leaving plenty of room for debate. What's truly puzzling is the long-term context. Around 245 million years ago, during the age of the dinosaurs, days were about an hour and a half shorter than they are today. Since then, Earth's rotation has been gradually slowing, primarily due to the moon's gravitational tug on our oceans. Scientists have been tracking this slowdown since official records began in 1973. But the recent speed-ups are a head-scratching reversal. Is this a temporary anomaly, or are we witnessing the start of a new pattern? And what does it mean for our planet's future? Here's where you come in. Do you think the moon's orbit is the sole culprit, or could Earth's core be playing a bigger role than we realize? Could these speed-ups have any long-term effects on our climate, ecosystems, or even timekeeping? Share your thoughts in the comments. This is one mystery that's far from solved. Why August 5th, 2025 will be one of the shortest days ever. The incredible shrinking day. Why August 5th could be missing precious time. Feeling like you can't finish your tasks on Tuesday? You might actually have science on your side this time. August 5th, 2025 is anticipated to be among the year's briefest days, with experts projecting it will be approximately 1.34 milliseconds shorter than our standard 24-hour cycle. And here's where it gets fascinating. This isn't just a random occurrence, but part of a pattern that's challenging our understanding of Earth's rotation. According to projections from both the International Earth Rotation and Reference System Service and the U.S. Naval Observatory, as reported by Time and Date, August 5th will continue a trend of unusually brief days we've been experiencing. This year alone, several days have dropped below the millisecond threshold, with July 11th being the most recent example prior to this upcoming event. It's worth noting that these scientific predictions don't always materialize exactly as forecasted. For instance, July 22nd was expected to lose over a millisecond, but ultimately only shed 0.87 milliseconds according to observatory measurements. To understand what's happening, we need to remember that our standard day consists of Earth completing one full rotation in precisely 86,400 seconds, 24 hours. However, this clockwork precision is more theoretical than practical in reality. The historical context makes today's changes even more remarkable. Before 2020, the shortest day ever documented by atomic clocks was just 1.05 milliseconds under the expected duration. As astrophysicist Graham Jones explained for Time and Date, since then, however, Earth has managed to shatter this old record every year by around half a millisecond. The current record holder for brevity occurred quite recently, July 5, 2024, when our planet completed its rotation 1.66 milliseconds faster than normal. This year's quickest spin so far happened on July 10th, coming in 1.37 milliseconds under the standard day length. But what's causing Earth to spin faster? This is where the science becomes particularly intriguing. Scientific American explains that two major factors influence our planet's rotation speed: changes in the Earth's core and atmospheric conditions. Surprisingly, the core's rotation has been decelerating for reasons scientists haven't fully determined. This creates a fascinating physical reaction. When the core slows down, the rest of the planet must accelerate to maintain angular momentum. The core is what changes how fast the Earth rotates on periods of 10 years to hundreds of years, explains Duncan Agnew, a geophysicist at the Scripps Institution of Oceanography. During the Northern Hemisphere's summer months, atmospheric forces naturally accelerate Earth's rotation rate. Additionally, lunar gravitational effects continuously influence our planet's spin velocity. Interestingly, when we zoom out to geological timescales, Earth has actually been gradually slowing down over millions of years. Scientific American notes that 70 million years ago, our planet completed its daily rotation approximately 30 minutes faster than it does today. Will you notice August 5th's missing 1.34 milliseconds? Almost certainly not. The difference is far too minute for human perception. But here's the crucial part most people overlook. These tiny variations create significant challenges for scientific and technological systems. Atomic clocks, which replaced traditional sun tracking methods in the 1950s, can measure time with astonishing precision, down to nanoseconds, billionths of a second. These globally synchronized timepieces establish Coordinated Universal Time, UTC, the foundation for countless critical systems. Even minuscule discrepancies in these ultra-precise measurements can potentially disrupt computers, servers, GPS navigation, and numerous other networks dependent on perfect timing synchronization. As experimental physicist David Gossard from the University of Western Australia told The Guardian, these seemingly insignificant time variations could have cascading effects on technology we rely on daily. Do you think these accelerating rotation patterns signal a concerning trend, or are they just normal variations in Earth's complex systems? Have you ever considered how these imperceptible time changes might affect the technology you use every day? Share your thoughts in the comments below. Earth's rotation speeds up. What could happen next? Shocking science insights. Get ready for the fastest day in modern history as Earth's rotation speeds up tomorrow. A shift so subtle you won't even notice it, yet so profound it could rewrite the planet's future. Here's what you need to know. Scientists have identified mysterious forces at play in our planet's spin cycle. Starting July 5th, or tomorrow, Earth will complete a full rotation 1.25 milliseconds faster than usual, chopping off precious fractions of a second from our 24-hour day. But here's the twist. This isn't merely a quirk of celestial mechanics. It's a potential warning sign. Why should you care about 1.25 milliseconds? While this tiny time slice seems negligible, invisible even to atomic clocks, researchers warn that prolonged acceleration could trigger catastrophic consequences across the globe. Picture this. As Earth spins faster, the constant tug of the moon's gravity and other forces push water away from the poles toward the equator, like a slingshot. Even a modest speed boost, 1 mile per hour, could raise sea levels by inches in equatorial regions. Cities like Miami or Jakarta, already battling floods, could find themselves submerged. But that's just the appetizer. If Earth's spin revs up to 100 miles per hour faster, entire coastal communities might vanish overnight as polar oceans surge southward. Survivors would face a world where biological rhythms are hijacked. Imagine waking up 2 hours earlier every single day because the solar cycle has shrunk to 22 hours. Studies show even minor time shifts like daylight saving changes spike heart attacks and accidents. A permanent swap? Chaos. The weather, is spiritually sourcing mysticism. And then there's the weather. A faster spinning Earth would amplify the Coriolis force, making hurricanes stronger and more destructive. Dr. Sten Odenwald, a NASA astronomer, says hurricanes will spin faster, pack more energy, and become harder to predict. This raises a critical question. Are we seeing natural fluctuations, or is human activity, like melting glaciers and El Niño events, accelerating this trend? The spinning record. Atomic clocks track these shifts with precision. In 2020 and 2022, Earth clocked its shortest days in decades. Last year, July 5th, shattered records, slicing off 1.66 milliseconds, a hair's breadth from the atomic clock era's shortest day since 1949. So why does this happen? Astrophysicist Graham Jones uncovered recent spins speeding up on specific dates, but the root cause remains elusive. It could be shifts in Earth's molten core, sea currents, or high-altitude winds. No 2 days are identical. Natural events like earthquakes and climate shifts reshuffle the Earth's spin axis. But wait, as alarming as these scenarios seem, Earth's rotation isn't always speeding up. Sometimes it slows. So is this a natural fluctuation or a sign of deeper turbulence? That's the million-dollar question. Your say. Should scientists intervene if Earth's spin continues to accelerate? Would you adjust to a 22-hour day or fight to preserve our traditional clocks? Share your thoughts below. In this era of climate uncertainty, no question seems too radical to ask. Note, all embedding dates referred to are from the original sources, as hyperlinks were excluded per formatting guidelines. N.